grade. I am so glad to see you again. Today is our last day to explore these adding two-digit numbers. Yesterday, we looked at two really different ways to solve adding these two-digit numbers. One of them being where we were breaking up our number into tens and ones and really think about partial sums and our base 10 blocks and how they can help us do that. But the second one we looked at, we really looked at how we can start with one number and add on to it. And we have to decompose that second number to make it easier to add, but we can start with that first addend, our first addend when we have two numbers added together. When we start with our first addend, we might have to break up that second addend to make it easier to add. Maybe we're using a number line where we're jumping to a friendly number or jumping a 10 to make it easier to solve. Today, we're going to be wrapping up with this. We're going to be paying close attention to the equations we write to match our work. Ooh, sounds hard, doesn't it? I have no doubt that you all will rock this and be fantastic mathematicians after this. In fact, you're already pretty fantastic mathematicians, I believe. Let's go ahead and get those targets ready, and we will get rocking and rolling. I can add two-digit numbers using models and equations. We did a lot of models yesterday. We're going to continue that today, but we're going to be paying close attention to those equations. Remember, those are those number sentences that we write to match our work. Let's go ahead and get started with our first problem. Remember, these problems make them a little bit more exciting, but we're really trying to add these two numbers together. Mr. Dane has 17 pens and 13 pencils. How many pens and pencils does Mr. Dane have? What numbers are we adding together? 17 and 13. Seem like small numbers after what we've been adding together, don't they? All right, how can we use the strategies we've already been using to help us add these two numbers together? Go ahead and get those tools out, those pencils out, and show me how you're going to tackle this problem. 17 plus 13 equals blank. Go ahead. What are you adding together first? Why? Oh man, those 10s are so easy to add. What equation would you write to match that? What did you add together first? Why did you add those two numbers together? They make a what? So then how many do we have all together? What equation would you write to match that? All right, friends, coming together in 5, 4, 3, 2, 1. Pencils down, done. All right. Talk to me over here, my love. What did you have? You drew 17. 1, 10, 11, 12, 13, 14, 15, 16, 17. And then what did you do? 10, 11, 12, 13, okay? And then what? Oh, that doesn't make 17, does it? Oh, golly bum. Ooh. Got a little dot happy, didn't I? All right, 17 and 13. What did you do next? You know 10 and 10 is 20, okay? And then what did you do? You knew 7 and 3 equal 10. You have 10 ones. And then what did you know? You know 20 and 10 is 30. Oh, I'm seeing some wiggle waggles. But I'm seeing wiggle waggles and then I'm seeing work on their paper and it doesn't match. How did you get the same answer but you did a different way? But you showed a different way. What did you start with? 17, okay, and then what did you do? Why did you add 3? Oh, it got you to 20. Okay. And then what did you do? And why did you add the 10? Ah, because 10 and 3 equals 13. And where did you land? And how did you know that you landed on 30? Because 20 and 10 more equals 30. Love it when that works out like that, don't we? Okay, but that's not what you did. What did you do? Anybody at home? What about you all? See these strategies that look familiar, or did you do something different? Ooh, I wonder if you did it the way that this friend did. What did you do first? 10 and 7. And 10 and 3. And what does the 10 and 7 represent? The 17. Ah, yes, that teen number, right? And what does the 10 and 3 represent? The 13. So what did you do first? You knew 10 and 10 was 20. 7 and 3 was 10. And 20 and 10 is 30. And where did you get that 3 in the 10's place? 20, 2 10s, and 1 10 equals 3 10s. 2 plus 1 equals 3. So 20 plus 10 equals 30. When we're adding these numbers together, what would be an equation, a longer equation to show the steps that we took to do this work? So this friend, 10 plus 10 plus 7 plus 3. Still got 30, right? But you added the 10 and the 10, the 7 and the 3, and you got 30. And that both goes together to make the one that you did. What about over here? And that was the same one over here. So this equation and this one might match, right? But that one wouldn't, would it? What equation would we write to match this work? 17 plus 3 plus 10. And what number did they decompose? They decomposed that 13. These two decomposed both of them. They decomposed the 17. They decomposed the 3, the 13. This one kept the 17 together and then broke that up. Just like yesterday when we were doing that work, decomposing those numbers to make them easier to solve. Sometimes you're decomposing both. Sometimes you're just decomposing or breaking up one. Oh, let's see if we can use what we know to help us solve this humdinger. I wonder if it's going to be as easy as the first one. What do you think? I don't think so either. Here we go. This one, ooh, you guys are going to show me 2 ways to solve 49 plus 26 equals, showing 2 ways. So you all have been showing me one way, but we've been adding so many different ways to our charts. I know you're not going to have any problem with this. Remember to use those public records that we've been using already to help you solve and show 2 ways for this one, 49 plus 26. And if you're at home, remember to pause me, give yourself some time to think, because we're going to jump right in to show the work for this. Let's go ahead and show those 2 ways to do our base 10 blocks. I have had 2 friends show me base 10 blocks, and neither of them were the same. Because you know that was possible. Let's see if you can find the difference. Ready? 49, 10, 20, 30, 40. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 26, 10, 20, 21, 22, 23, 24, 25, 26. Oh, I'm seeing some hands up. What am I doing? Adding our 10s. that friend do? They found that 10 of the ones. Looked a lot like this one, didn't it? Where's that 10? We had one of those yesterday too. 6 10s and one more 10 makes 70. And then we have our 5. I have another base 10 block piece of work to show you. I want to see if you can figure out the difference. Okay? Hope I don't get too dot happy, right? Okay. 49. And then what did we do? $59, $69, $70, $71, $72, $73, $74, $75. Counting on, starting with that bigger number, adding the 10s, and then adding those 1s, but still counting on. Okay, I've got a number line, and then I've got something else to show you. Okay, so let's take a peek at our number line, and I want you to figure out which base 10 blocks, which set of base 10 blocks the number line matches, or is closest to, I should say. All right, here we go. Here's this number line. And I'm seeing some friends go up. I don't see them straight on, but I can see their little hands. They're getting so excited. Doesn't match exactly. What did that friend do? Similar to this one. Why is it similar to this one? They both started at 49. Okay. Is it exactly the same? Why not? This friend just counted on. So they counted on by 10s and then by 1s, right? And so this person kind of decomposed the 10s and the 1s. What did this person do? Made one jump to 50. There's that 10 as a friend, yes. And then another jump of 20. And then they jumped, and then they broke up the 5, or the 6, 26, but that extra 5. So where's the 26 in this piece of work? It's in those jumps. In our equation, it's right here. Starting with the 49, then adding the 1, then adding the 20 and the 5 to get to that 75. Absolutely. So we want to make sure that we're seeing both of those numbers in that work. We're seeing the 49 and the 26 here. 49, 26, 49, 26 in the jumps. Now, I want to show you the last strategy, and I want you to vote which one is the most efficient. Now, most efficient might not be the same for everyone, okay? What might be efficient for me may not be efficient for my friend here. What might be efficient for my friend here may not be efficient for my friend here. For me, this one's not efficient because I'm not always very good about counting on. It's easier for me to break it up into 10s and 1s. But is it easier for me to do it with base 10 blocks or partial sums? Some of us are really fast at writing that number line and chunking up that second number. And that might be the most efficient strategy. But I'm going to show you one more, and then I'll let you vote. You can write me a little note and tell me which one's your most efficient one. Or better yet, when we do our exit task or when we do our independent practice, you all can show me your most efficient one by putting it to use. All right, last one. My friend did this. 40 and 9. 20 and 6. 20 plus 40 is 60. 9 plus 6, 15. And how did they get 15? 9, 10, 11, 12, 13, 14, 15 is that sixth one. And then what do they do? Decomposed. So we have 60 plus 15 is the same as 70 plus 5, and we get 75 as our sum. I want you in your work today to show me which one is the most efficient one for you by using it. Challenge accepted, right? Okay, second graders, you've been doing lots of fantastic work, and you have some more practice to do at your seats. Put to use all of these amazing ways that you can solve. And remember, you're choosing a strategy that's going to work best for you. You might decompose one number, you might decompose both. But I want you to use those base 10, or I want you to use our public records to help you figure out which one works best for you. Happy solving! You guys have been such great learners this week.